The moon is one of the harshest environments in the solar system. In direct sunlight, its surface reaches 260 degrees Fahrenheit, hot enough to melt lead. In shadow, it plunges to negative 280 degrees Fahrenheit, colder than almost anywhere on Earth. There is no atmosphere to hold heat, no weather, no protection, and yet, hiding in the darkest corners of the lunar poles, there is water ice, not ancient dry rock, not dust, ice, frozen water, sitting on a world that gets blasted by the full power of the sun with nothing between them. How is that possible? Why hasn't the sun melted it? And how long has it been sitting there? The answer involves some of the strangest geometry in the solar system, and it changes everything about humanity's future on the moon. To understand how ice survives on the moon, you first need to understand why the moon is so different from Earth. Specifically, why it has no protection from the sun at all. On Earth, the sun's energy is filtered, redistributed, and moderated. Our atmosphere absorbs and scatters solar radiation. Our oceans store and release heat across seasons. Our magnetic field deflects the most energetic solar particles. The result is a planet where temperatures, while variable, stay within a range that allows liquid water to exist. The moon has none of that. No atmosphere to speak of, no ocean, no magnetic field, no way to moderate what the sun sends its way. When sunlight hits the lunar surface, it hits directly, unfiltered, unreflected, unmoderated. The surface heats dramatically. When the sunlight moves away, the surface cools dramatically. The moon swings between extremes that would be lethal to any exposed organism. So the question of how water ice survives on the moon is not a small puzzle. It is a question about how something as fragile as frozen water exists on a world specifically designed, by its physics, to destroy it. Let's walk through the answer. Step by step, Step 1. The tilt that changes everything. Earth is tilted on its axis at 23.5 degrees relative to its orbit around the sun. That tilt is what gives us seasons. In summer, a hemisphere tilts toward the sun and receives more direct light. In winter, it tilts away. The moon's axial tilt is dramatically different. It is tilted only about 1.5 degrees. This is almost no tilt at all. The consequence of this tiny tilt is extraordinary. Because the moon barely tilts, the sun never rises very high above the horizon at the lunar poles. From the surface of the moon's north or south pole, the sun appears to circle the horizon, always low, always grazing, never climbing overhead, and that means that the bottoms of craters near the poles, deep craters with steep walls, never receive direct sunlight at all. Step 2. The permanently shadowed regions. These areas are called permanently shadowed regions, or PSRs. They are craters, depressions, and low-lying areas near the lunar poles, where the sun's rays have never directly reached, possibly for billions of years. The walls of these craters are tall enough, and the sun is low enough, that no matter what position the moon is in during its orbit, direct sunlight cannot reach the floor. These regions are extraordinarily cold. Temperatures inside permanently shadowed regions can drop to negative 400 degrees Fahrenheit, negative 240 degrees Celsius. That makes them among the coldest naturally occurring places in the solar system, colder than Pluto, colder than the surface of Neptune. And in that extreme cold, frozen water does not melt, it does not evaporate, it stays. Step 3. Where did the water come from? If the moon has no water sources of its own, how did ice get there in the first place? Scientists believe the water arrived from multiple sources over billions of years. Comets and water-rich asteroids have been bombarding the inner solar system since its earliest days. When these objects struck the moon, the heat of impact vaporized their water content. Most of that water vapor dispersed into space, but some of it migrated, molecule by molecule, toward the poles, where the temperature was cold enough to trap it. Over billions of years, those migrating molecules accumulated. Additionally, the solar wind, the stream of charged particles constantly flowing from the sun, contains hydrogen atoms. When those hydrogen atoms strike oxygen-containing minerals on the lunar surface, they can combine to form water molecules. This process, called solar wind implantation, is slow, but over billions of years it contributes to the water budget. The ice in permanently shadowed regions is therefore ancient, a collection of water molecules that arrived over geological timescales and found the one place on the moon cold enough to hold them, Steep 4. The confirmation for decades the existence of lunar ice was theoretical. Scientists suspected it based on the geometry of the poles and the physics of cold traps, but direct confirmation was difficult. In 2009, NASA deliberately crashed the LCROSS spacecraft into Cabeus crater near the moon's south pole. The impact plume was analyzed by a following satellite. The result was confirmed. Water ice was present in the permanently shadowed regolith, roughly 5.6% by mass in the impact area. In 2018, a study using data from NASA's Moon Mineralogy Mapper instrument aboard India's Chandrayaan-1 spacecraft provided direct infrared evidence of water ice exposed at the lunar surface in permanently shadowed regions near both poles. This was not just indirect detection, this was ice at the surface observed directly. Here is where the physics becomes genuinely remarkable. The permanently shadowed regions of the moon are what scientists call cold traps. A cold trap is a region so cold that any volatile substance, water, carbon dioxide, ammonia, that enters will freeze and stay frozen essentially indefinitely. The physics behind this involves vapor pressure. Every substance has a temperature at which it begins to evaporate. Even solids can evaporate directly into gas through a process called sublimation. Water ice sublimates slowly at extremely low temperatures, but at -400 degrees Fahrenheit, the vapor pressure of water ice drops to essentially zero. There is no mechanism left to turn the ice into vapor and remove it. The ice is, in a physical sense, trapped. It cannot leave. What makes this even more extraordinary is the stability timescale. Modeling suggests that water ice in the deepest permanently shadowed regions of the lunar poles has been stable for billions of years, perhaps since the early solar system. This ice may be a record of the solar system's early water delivery, preserved at extraordinary fidelity in a natural deep freeze on a world with no weather to disturb it. But here is the twist that makes the moon's ice story even stranger. The permanently shadowed regions and the sunlit surface exist just meters apart, sometimes mere centimeters apart along the boundary where shadow meets light. At that boundary, the temperature swings from -400 degrees Fahrenheit in the shadow to over 200 degrees Fahrenheit in the sunlight. A temperature difference of 600 degrees Fahrenheit across a distance a human being could walk across in a single step. Nowhere else in the solar system known to science does such an extreme temperature gradient exist over such a short physical distance. And there is a second twist. Because the sun is always near the horizon at the lunar poles, the ridge tops of the craters that contain permanently shadowed regions are actually in nearly continuous sunlight. These crater rims are sometimes called peaks of eternal light, high points where the sun never sets, where solar energy is available almost continuously. A future lunar base at a pole could place its solar panels on a peak of eternal light just a few kilometers from a permanently shadowed region containing ice, clean, virtually unlimited solar power located almost within walking distance of water. So here is what all of this actually means. The moon, which looks like a barren, hostile, waterless world, contains what may be hundreds of millions of tons of water ice, frozen into the permanent darkness at its poles, preserved for potentially billions of years. That water is not just scientifically interesting. It is strategically important in a way that is changing how space agencies think about the moon entirely. Water can be split into hydrogen and oxygen through electrolysis. Oxygen is breathable. Hydrogen and oxygen together make rocket fuel. A base near lunar ice could, in principle, not only sustain life but manufacture the propellant needed to leave the moon and go further, to Mars, to the asteroid belt, to the outer solar system. The moon's ice is, in the most literal sense, a potential refueling station for the human expansion into the solar system. NASA's Artemis program has specifically targeted the lunar South Pole for future crewed landings for exactly this reason. The South Pole's permanently shadowed regions are considered one of the most valuable real estate zones in the entire solar system. Here's the thought that should stay with you. Water ice survived on the moon not because the moon is safe or gentle, but because geometry created a loophole in the sun's reach. The moon barely tilts. The sun never climbs high at the poles. The walls of polar craters block it completely. And in that narrow shadow, in regions untouched by sunlight for billions of years, frozen water accumulated, molecule by molecule, from comets and asteroids and solar wind, building up in the cold silence of one of the most extreme environments in the solar system. Ice on the moon is not an accident. It is physics finding a way, and the same sun that burns the lunar surface to 260 degrees every day has been powerless against it, because it simply cannot reach where the ice lives. The moon hid its water in the one place the sun cannot go, and we found it.